First problem on your review is to write the equation for your axis of symmetry. So let's first draw my axis of symmetry. Remember, it goes through the vertex. So my axis of symmetry will be this. And my equation is x is equal to, and since it's going through 2 on my x-axis, it's going to be x is equal to 2. For this one, same idea. Our axis of symmetry is going to go through my vertex. This is my vertex. Again, my equation starts with x equals, and it's going through -2. So my equation is x is equal to -2. Whenever we write the inverse of any function, inverse is basically when we just switch the x for the y and the y for the x. So to write this set of points, or the inverse of this set of points, we're going to switch the x and the y. So now we have 3, 1. Then we have 4, 2. And then finally we have 8, 6. Where your x's are now your y's, and your y's are now your x's. Okay, we need to identify the vertex of this function. Now for anything in vertex form, we've got ax minus h squared plus k, where your h and your k are your vertex. It's the y and the x. And remember, your x always lies, so it's always opposite of whatever it is on your equation. So in this case, we've got +6, x lies, so your h is actually -6. For this one, we have -4 is your k. So when we write our vertex, we've got -6 and +4. Same idea for this one. If we need to find the vertex, we look at this number, that's h. Remember, it's always opposite sign. So it's a +5. Your k is equal to 2. So our vertex is at 5, 2. To find the domain and range in interval and inequality notation, remember domain is your x, your range is your y. So when we're looking at our domain, we're looking how far the function goes left and right. So if we're looking at it to the left, there's an arrow, so it's going to go to positive infinity. And if we're looking at it going to the right, because there's an arrow, I'm sorry, this is, all right, so for number 5, we need to write the domain and range in interval and inequality notation. Interval notation is when you use the brackets or the parentheses. Inequality notation is when we use our inequality signs. So domain, if you can remember, is your x values, your range are your y values. So if we're looking at this function, to look at our x values, we want to go how far does it go to the left and how far does my function go to the right. So on the left, it's approaching -infinity because there's no end. For the right, there's also an arrow, so there is positive, it goes up to positive infinity. So for my domain, in interval notation, it goes from -infinity to positive infinity. And we need to use parentheses because infinity always has parentheses. Now to find the range are your y values. So we go to the lowest point and the highest point. So this is my lowest point, and the lowest point is at 5. And because it's including the 5, we're going to use a bracket. And then we want to look at the highest point. The highest point is there's an arrow, so it's going to go to positive infinity. So to write my range in interval notation, my lowest point is at 5. It's including, so we're going to use a bracket. And my highest is infinity. And we're going to use a parentheses because we always use parentheses for infinity. Now in inequality notation, we use the same numbers. But for your domain, because it's going from -infinity to positive infinity, we call it all real numbers. Now for our range, all of our y values need to be greater than or equal to 5. And that includes infinity. So all of my y's will be greater than or equal to 5. Okay, let's look at this problem. Notice how this is a discrete function. So it's discrete because we have points and they're separated. So for my domain and my range, we're going to write it as a set. So we look at our x values because we're finding the domain, and the x value for this point is at -4. The x value for this point is at -2. The x value for this point is at +1, and the x value for this point is at +2. So the x values that we're using for this function is -4, -2, 1, and 2. Now for the range, we're going to now look at our y values. Look at the lowest one. We've got 2. This one has a y value of 3. This point has a y value of 4. And this point has a y value of 6. So the y values, or the range in this function, are 2, 3, 4, and 6. So to find the solution for a system that is graphed, we look for the point of intersection. And the point where these two lines intersect is at this point here, where it has an x value of -6 and a y value of -7. So our solution is at -6, -7. Now for these two, you can use Desmos, where you can graph both of them so you can check your answer and then find the point of intersection. But we're also going to be solving this using elimination or substitution. So make sure that you check your work on the Desmos calculator. All right, so for these two, because our x's and y's are lined up, we're going to use the elimination method. Now for us to be able to use the elimination method, your variables have to be complete opposites of each other. So if you notice here we have a 2y. In order for us to eliminate that 2y with this one would have to be -2y. So an easy way that we can do that is by multiplying this whole thing by -2. So I'm going to rewrite the first equation. And then the second equation, I'm going to distribute that -2. So this becomes -14x minus 2y equals -38. And notice how now these y's are complete opposite of each other. So we're going to eliminate those, and then we're just going to add down. So 3x plus -14x gives us -11x. 16 plus -38 gives us a -22. Then we're going to divide by -11, and x is equal to 2. Now that we know our x value, we can go back in, plug it into whatever original equation we have, and then solve for y. So I'm going to use the one with the smaller numbers, which is my first. 3x plus 2y equals 16. We're going to substitute that x value of 2. So we get 6 plus 2y equals 16. And y is equal to 5. So our solution would be at 2, 5, which means if we were to graph it on the Desmos app or calculator, their point of intersection would be at 2, 5. Okay, for the next one, we're going to solve using the substitution method. Since the y is already solved for, we're going to use this expression and we're going to plug it into the second equation where the y is. So I'm going to rewrite it. We've got 2x plus 2 times, that's what we're going to insert that for x plus 1, because that's substituting that y, is equal to 13. So we've got 2x, 2 times 4 is 8x, 2 times 1 is 2. Okay, now we're going to combine like terms. We get 10x plus 2, 13, subtract 2. 10x is equal to 11 divided by 10, and x is equal to 11 tenths. Now let's go ahead and solve for y. We're going to use this original equation since it's set up nicely for us, where we just plug in our x, and then we're going to plug in that x value. So 4 times 11 over 10 plus 1, so 44 divided by 10 plus 1. Because remember, we put it over 1 and then we just multiply across. We're going to simplify that number by dividing it by 2, so we get 22 over 5 plus 1. And to be able to solve for when we have, to be able to solve a fraction when we add a whole number, we're going to change that whole number where your 5 is the denominator, which would be 5 over 5, because 5 divided by 5 is equal to 1. So just bring that one down, and now we have 27 over 5. 22 plus 5 is 27, and we keep the denominator. So our solution would be at, this is our y, 11 over 10, 27 over 5.